Good morning, class. Welcome. Today we'll be working on system of linear equation, continuing the process. We were working on system of linear equation where we have two equations and two variables. Now, what we are working on today, class, is that we have three equations and three variables. So these are a little bit more complex than the one we were doing. Nevertheless, these can be solved by the same method. A good thing to do would be to inspect the system of linear equation and try to select two equations at a time and eliminate the same variable. In doing so, you will end up with a system of two equations in two variables, and we'll solve for those variables and go and do back substitution and solve for the remaining variable. So that is what we intend to do. There is more than one way to solve these problems, system of linear equation in three variables. We can of course use determinant and expand the determinant by using minor and cofactor, which we will also attempt. Now, if you look at this system of equation here, you will see that I'll call this here equation 1, this 2, and this 3. You will see that if you take equation 1 and the second one and you add them, that you will eliminate y. And you can pick this out by doing a careful inspection of the whole system of linear equation. And then let's go ahead and do that. So for 1, I have x plus y plus z equal to 6, and I have 2x. For 2, I have 2x minus y minus 3z equal to minus 5. Now, I will go ahead and add these two equations, and by doing so I get plus y and minus y cancel off, and this gives me 3x minus 2z equal to 1. I will call this here 4. Now, on further inspection of that system of linear equation in three variables, the original, you can also see that if you take the second one and the third equation and you add them, we can also eliminate y. A good strategy would be trying to eliminate the same variable, because with these problems you can make it easier or you can make it more difficult. But we don't want to make it difficult, we'll try to make it more simple. So that's why it called for some inspection. And then if we use 2, it is 2x minus y minus 3z equal to minus 5. And I use the third one, 4x plus y minus 3z equal to 5. I will go ahead and add it now. And you will see that I have here, this gives me 6x, and plus 1 minus y cancel off, and here I have a negative 6z equal to 0. So I have here, I'll call this here 5. Now, by using this one, 4 and 5, I now have two equations in two variables, as I initially said. So let's go ahead and write these down. Here I have 4 is 3x minus 2z equal to 1, and by 5 we have 6x minus 6z equal to 0. So we'll go ahead, we know how to do this, we have done this several times, and this one here is going to be easy now because we don't have three variables here. And we see that by inspecting 4, that if we multiply that by a -2 and add it to 5, equation 5, we can eliminate the x. So any questions, student, so far? Any question on what we're doing? All right. Now, let's go ahead and do that. So we multiply this here by -2. And if you do that, this becomes -6x minus plus 6z equal plus 4z. 6 minus 6x plus 4z equal to -2. All right. And this one here, we rewrite it as it is. It's going to be 6x minus 6z equal to 0. And then we'll go ahead and add. All right. Are we all on the same page here? Now, let's go ahead and add. And if we do that, this minus 6x and plus 6x cancel off, and this gives us -2z here equal to -2, and then we divide both sides by -2, and we get z equal to 1. So now we have one of our variable has a solution here of 1. So we'll go back here now and back substitute in this one here, in this system of 2 equations and 2 variables, and solve for our x. You can choose any one. So let me go ahead and choose this one here. 6x minus 6 times 1 equal to 0. 6x minus 6 equal to 0. 6x equal to 6. That implies that x equal to 1. So here we find both the values for x and z, and both of them have value of 1. So we'll go ahead and use an equation from the original system and do back substitution and solve for the value of the remaining variable. And here again, you can use any one of these. Any questions so far? Okay. All right. So I will go ahead and use the top one, 1, and this is x plus y plus z equal to 6, and this tells me here that 1 plus y plus 1 equal to 6, 2 plus y equal to 6, and y equal to 6 minus 2, which is equal to 4. So y equal to 4. And our order triple, x, y, z, is going to be equal to 1, 4, 1. All right? So that's our solution. The order triple. X equal to 1, y equal to 4, and z equal to 1. Now, you may want to check your answer. To check this answer, you can easily go back and substitute those values for x, y, and z into these equations. And if you do that, you find that x is 1 here, y is 4, and z is 1, and that gives 6. You can try it for the other one, and you will get a situation where they are equal. So that is our solution. Now, there is another way to do this problem. There is more than one way. Another way, as I mentioned to you, is that we can use determinant, in which case we will extract the coefficient of the variable and find the determinant for those, the coefficient, and then we will find the determinant. We usually call it with respect to x, the d sub x, by replacing the coefficient of x with this constant column. So this here is our constant column. And these coefficients of x, y, and z, they will form the matrix for D. And by interchanging your x column or the y column or the z column with this constant column, we'll find the determinant with respect to x, the determinant with respect to y, the determinant with respect to z, and then we'll find the value of x, y, and z. So let me take this off. We'll take this off, and what will happen here is that our x, y, and z, after we find the determinant, or x is going to be equal to d sub x over d. Y will be equal to d sub y over d. And z is equal to d sub z over d. Alright, those are all determinants. So we will need to find 4 sets of determinants. And then we'll solve for x, y, and z using this little formula I put up here for each one. Any questions, students, so far on what we are doing? All right, feel free to participate and ask questions. All right, now I will go ahead and take this off and form our matrix. Now, if I extract my coefficient and place them in here, and I put the constant term to the right, I'll get 1 here, 1, and 1, because the coefficient for all those variables are 1. Then I have a 2 for x, negative 1 for y, and negative 3 for z. I have 4 for x, 1 and minus 3 for z. And I put to the right of this vertical bar, I'll put 6 minus 5 and 5 here. And what I have formed here, class, this is what we call the augmented matrix. This here is the augmented matrix. All right. So now I will go ahead and find the determinant for those coefficients. That is going to be our main one. That is what we will divide by to find the value for x, y, and z. So D here, the determinant of the coefficient of the variable, is going to be 1, 1, and 1 here, 2, minus 1, minus 3, 4, 1, and minus 3. So these here are the coefficient of the variables x, y, and z, which I get from here. What I will be doing is that I will expand this determinant, this 3 by 3, which is a square matrix, by what we call the cofactor and minor. What this is, it says that if A is a square matrix, then the minor of the entry in the ith row and jth column, they're also known as the ij, minor, is the determinant of the submatrix formed by deleting the ith row and the jth column. So we'll be deleting the ith row and the jth column, and we'll be using the remaining elements or numbers to find the cofactor. Now, for every square matrix, students must know that there exists a real number called the determinant. Now, let's go ahead and find the determinant here by what we had said, the cofactor and minor, by expanding. Now, if I do that, now I'll start out with the element 1 or the number 1, and then I'll get a submatrix of 1 column and 1 row less. So this is going to be no element from the first row and the first column will be included. So I have a negative 1 and a negative 3 here. and I have a 1 and a negative 3 here. Then, as we move across, I want to inform you that the ij cofactor is obtained by multiplying the minor by -1 to the exponent I plus j. So then, if I take -1 and I multiply it by, here our row is 1, the first row, and the column is the second column. So 1 plus 2 is 3. So -1 to the third power is going to give me a minus. So this is -1 because my element here is 1. And then I will have here, number 2, -3, and 4, and -3. Because remember, in this case now, I'm deleting the first row and second column. Then my next one would be +1, which I get from the first row and third column. And then I'll be using here the number 2 and -1, 4 and 1. So now, I had mentioned before how to find the determinant. What we'll be doing is that for the 2 by 2 matrix, the square matrix, we will multiply the element in the diagonal, the main diagonal, and take the product of that diagonal and subtract the product of the other diagonal, product of the numbers in the other diagonal. So then this will give me here 1 times -1 multiplied by -3 is 3, minus a negative 3 times 1 is -3. This is a -1, and I will continue the process. Any questions so far on how we are finding the determinant? Feel free to ask any question you have. So then, this is going to be 2 times -3 is -6, minus a negative 3 times 4 is 12, plus 1 time, 2 times 1 is 2, minus 4 times -1 is -4. And now we'll go ahead and simplify whatsoever we have in those parentheses there, and then add. And that should give us our determinant D. Now this process is a little bit lengthy because there's a lot of work involved, but nevertheless we are going to do it. So then this is going to give us a plus here, 2 negative, give us a plus, and then this is going to be 1 times 6, 3 plus 3, 6, minus 1 time, -6 plus 12, so this is going to give us a plus 6 here, plus 1 time 2 plus 4 is going to give us 6 here. So let's go ahead and evaluate then this, what we have here. So then this is going to be equal to 6 minus 6 plus 6, and this gives us 6. So our determinant here, D, is equal to 6. Now, this is what we'll be dividing by. So we'll be now finding the determinant with respect to x by replacing the column, the coefficient of x, with the constant column. And then we'll get d sub x. So this is our d. Now d sub x then, let's make that matrix. D sub x is going to be equal to 6, -5, and 5. So you see what we have done there. We have replaced the column that consists of the coefficient of x by the constant column. And the other two columns, the coefficient of y and z, will remain the same. So let's go ahead and do that. So then this is going to be 1, -1, and 1. And this is going to be 1, -3, and a -3. And then we'll find the determinant of this. That will give us d sub x. And that is what we'll take and divide by d. And we'll get the value for x. We will repeat the process for y and also z. Do the same thing and we'll find the value for y and z. So, everybody confident about what we're doing? All right. So then this is going to be equal to, so I'll expand here by this first row here. So remember, we are not going to be using elements in the row and column where this number lies. So we have a 6 here, and then we are going to use -1, -3, 1, and -3. And this is going to be -1 times -5 and -3, 5 and -3, and then we have a +1 times, we are not going to use anything in first row and third column, so we use -5 and -1, 5 and +1. Now let's find the determinant for this. So this is going to give us 6 times -1 by -3 is +3, minus a -3, -1 times 5 times 3 is 15, minus a -15, plus 1 times -1 times 5 is -5, minus a -5. So we have to be very careful with our signs. There's a lot of sign involved here, and we don't want to get it mixed up. So then, this will give us plus 2 negative. So then this is going to be 6 times 6 minus 1 times 15 plus 15 is 30. And then this is going to give us plus 1 times -5 plus 5. So if we simplify this a little bit, this will give us 36 minus 30, and then this is going to give us here 1 times 0, and this is going to give us 36 minus 30, and this gives us 6. So d sub x class is equal to 6, which is the same also as the determinant d. Now that we have found the value for d sub x, then let's go ahead and find the value for x. Then x is going to be equal to d sub x over d, which is equal to 6 over 6, and that's equal to 1. So, you see what we have done there? We have found the value for x using determinant, and we expand by what we call the minor and cofactor. All right? Now, let's go ahead and find d sub y. It's a lengthy process, but this is it's like repeating the same thing over again, except we'll be switching, replacing the column. So then, for d sub y, our matrix we are interested in, our x remain the same, 1, 2, and 4. We replace the x column with the coefficient, the constant column, which is 6 minus 5 and 5. The z remain the same, minus 3. And this is what we will find, the determinant of this. And then, if we repeat the process here, we will get here, will give us 1 time minus 5 and minus 3, 5 and minus 3. This is going to be minus 6. The way we get 6 here is because, remember, we replace the coefficient of y by the constant column. And this is minus 6. The element we want here, or the number, would be 2 and minus 3, 4 and minus 3. We are not going to use anything in the second column. And then we have here plus 1, and our number are going to be 2 and minus 5, 4 and 5. And if we evaluate this here, we will get 24. So d sub y equal to 24. And right away then, if we go ahead and we find for y, y is equal to d sub y over d, which is equal to 24 over 6, and that gives you 4. So y equal to 4. Now, let's go ahead and find the value for d sub z, the determinant, by replacing the z column, the coefficient of z, with the constant column. And I need some more space. Do that here, so I'll take out this. And we do that, this is what our d sub z will be like, or x and our y coefficient remain the same. We replace the z with 6 minus 5 and 5, and then we will expand by our minor and cofactor, and then this is going to be 1 times minus 1 minus 5, 1 and 5, minus 1 times 2 and minus 5, 4 and 5, and then this is going to be plus 6, and the number we need here are those that are not in the first column and third row, be 2 and minus 1, 4 and 1. Now, if we do this here now, we will get 1 times minus 5 minus a negative 5, minus 1 times 2 times 10 minus a negative 20, plus 6 times 2 ones 2 minus a negative 4, and this will give us 6. So then our d sub z equal to 6 and z equal to d sub z over d, and this is going to be 6 over 6, and this is 1. So z equal to 1. So our order triple is going to be x, y, z is going to be equal to 1, 4, 1. X equal to 1, y equal to 4, z equal to 1. And we can go back and check it. If you are not sure that this is the solution for order triple, you can go back and put the value here. Let's check it. X is 1, plus y is 4, plus z is 1, and this is 6. Then 6 equal to 6, and this is true. And you can use any other equation in the system and check it. So this is going to give us 4 times 1 plus 4 minus 3 times 1, and this is going to be 8 minus 3, and this is 5, and this is true. So you can check it further. So this class is what we call using determinant and finding the solution to the system of linear equation, because those coefficients of the variable form a square matrix, and as I had said, for every square matrix there is a real number associated with that matrix called the determinant. And we expand the matrix by what we call minor and cofactor. So we get another submatrix there, and the process repeats itself. Now I must mention here that there are situations where a system of equation in these three variables as others may not have a solution. And in such cases, if it does not have a solution, you'll say that the system is inconsistent. And you will find that that is so. And how do you know? It's because when you try to solve it, take two equations at a time, you may arrive with a false statement at a false statement. And when you get a false statement, you would know that that system has no solution. It's inconsistent. So we'll go ahead and work one of that also. So then, let's go ahead and solve a system and see whether we have a solution or not. I'll take this off to make some space, and let's go ahead and solve that system of linear equation. So is everybody comfortable then with solving system of linear equation in 3 variable in at least, let's say, 2 or 3 different ways? So we have done it by the usual method of elimination and so on, and back substitution, and then we have also done it by using determinant and by using what we call expanding by the minor and cofactor, by cofactor. Okay. Now, the 3 by 3, as I mentioned, are a bit more complex than the 2 by 2, and we have done the 2 by 2 a lot. Now let's look at the system of linear equation here. I have one here which I'll put up on the board. X minus y plus 3z equal to 1. 3x plus z equal to 0. And minus x plus y minus 3z equal to minus 5. All right. So we have here, class, another system of linear equation in 3 variable. Now, as I mentioned to you that some systems don't have any solution, or we won't know until we perform some operation on this one here and see if we come up with a false statement. We don't know yet. But by inspection, that's why it's good to do this. If you look at the system of linear equation in 3 variable here, take some time and look at it, because you don't want to go and work it and waste your time when it has no solution. Let's look at this here. If we look at equation 1, the top one, and we look at the bottom one, we see that we can go ahead and add something here, add in here. So let's go ahead and put, call this 1, 2, and 3. 1, we have x minus y plus 3z equal to 1. And this is the third equation. I have negative x plus y minus 3z equal to minus 5. Now, let's go ahead and add and see what will happen here. Anybody have any question on this? You're welcome to bring up any question you have. So let's go ahead and add. Plus x and minus x cancel off. Negative y and plus y cancel off. 3z and minus 3z cancel off, and we get 0 over here. Or when we add the right hand side, 1 plus negative 5 will give us negative 4, and we get here a false statement. False statement. So that tells you right away that this system has no solution. We get a false statement. It's inconsistent. The system is inconsistent. And this is so when you get a statement like this. So you don't want to waste time with it. If you, by inspecting it, you're able to do these operations and tell. Any question, class, on what we have done so far? All right, we'll be working further later on and do some more of these system of linear equations, solving them by determinant and by the traditional way, and of course we'll become familiar with expanding by minor and cofactor and so on. Any question? Thank you, and make sure you do those examples you have. I'll come around and check those. It's good for enhancing your problem solving skill. I must emphasize that there are some real life applications with these kind of problem also, which we'll apply and use later on. Thank you very much.